Manual adjustments of a surgical microscope consume at least 10% of surgery time. It also creates a potential risk to patient safety during operation. Consider the risks taken when the surgeon has to take his hands off surgical instruments to adjust the microscope settings during a critical situation. What if we could design a hands-free surgical microscope in which the surgeon could use gaze interaction to adjust the microscope settings? These settings could focus, zoom, or change the light intensity. For the first time in use in microsurgery, we introduce the iMic, a binocular eye tracker that can be attached on top of any microscope ocular. Its height of only 5 mm means no limitation on the field of view. In this replay video, we can see the accuracy of our system in estimating the surgeon's gaze when following a 5 mm object under 10 times magnification. We are a team of experts in medical eye tracking, robotic, and international business with over 7 years research background in the field. We aim to allow surgeons to change the way they interact with the surgical microscope by developing a head and eye tracking system for hands-free control of a robotic microscope. Our initial test showed the task completion time is 2 times less for the hands-free microscope when compared to hand-based interaction microscopes. Although surgical microscopes are used in ophthalmic surgery, otolaryngology surgery, plastic and reconstructive surgery, dentistry and other surgical domains, we focus on neurosurgery because we believe that neurosurgeons will get the most value from our product. Our prototype is ready, and now we are looking for an industry partner for end user expertise and prototype evaluation.